Bismillahirrahmanirrahim. Assalam O Alikum. Dear student, welcome to my YouTube channel Learn with Azam. Today we will discuss about new syllabus Punjab Book Foundation Physics SSC 2 Unit number 13 in electrostatics. Today we will discuss about SLOBs according to FBISC requirement numerical problems question number 8 to 10 in part 3. Let's start numerical problems question number 8. In question number 8 given statement a capacitor holds 0.03 coulomb of charge when fully charged by the 6-volt battery. How much voltage would be required for it to hold 2 coulomb charge? So according to the statement, first of all write the given data. Now charge Q1 is equal to 0.03 coulomb and charge Q2 is equal to 2 coulomb. The attached battery voltage V1 is equal to 6 volt. Now required that the voltage V2. So finding the voltage V2 we can use the formula equation for first capacitor Q1 is equal to CV1 and Q2 is equal to Q2 CV2. Now we dividing the equation 1 by equation 2. So V2 is equal to Q2 multiplied by V1 divided by Q1. So for solution putting the values V2 is equal to Q2 multiplied by V1 divided by Q1. So V2 is equal to 2 multiplied by 6 divided by 0.03. So the answer of voltage V2 is equal to 400 volt. Then the result of question number 8 voltage V2 is equal to 400 volt. Now in question number 6 numerical problem question number 9. Two capacitors of capacitance 6 microfarad and 12 microfarad are connected in a series with the battery of 12 volt. Find the equivalent capacitance of the combination. Find the charge and potential difference across each capacitor. According to statement, write the given data. Capacitance C1 is equal to 6 microfarad. 1 micro is equal to 10 raised to power minus 6. So C1 is equal to 6 multiplied by 10 raised to power minus 6 farad. And capacitance of capacitor C2 is equal to 12 microfarad. 1 micro is equal to 10 raised to power 6 minus 6. So C2 is equal to 12 multiplied by 10 raised to power minus 6. Here not a 6, we use 12 multiplied by 10 raised to power minus 6. So voltage V is equal to 12 volt. Now we can require that equivalent capacitance CEQ and in second part charge of each capacitor Q and in next part C potential difference across each capacitor V1 and V2. So using the formula first of all equivalent capacitance 1 upon CEQ is equal to 1 upon C1 plus 1 upon C2 and for second part Q is equal to CV and third part we also use Q is equal to CV but rearrange the formula. Now for a solution first part we can write that the solution of A part since capacitors are connected in series. So the capacitance 1 upon C equivalent is equal to 1 upon C1 plus 1 upon C2. Putting the values, then 1 upon CEQ is equal to 1 upon 6 plus 1 upon 12. So answer of equivalent capacitance 1 upon C equivalent is equal to 3 upon 12. Now taking the reciprocal, and 12 divided by 3 is equal to 4. So equivalent capacitance is equal to 4 microfarad. So for our next part, B part, Q is equal to CV. Here equivalent capacitance C is equal to 4 microfarad. So we use C is 4 microfarad and voltage V is equal to 12 volt. So putting the values, Q is equal to 4 multiplied by 10 raised to power minus 6 multiplied by 12. 12 fours are 48, then Q is equal to 48 microcoulomb. Now we can find the capacitance. So here Q is equal to C1 V1. Then V1 is equal to Q upon C1. Here 48 divided by 6, that will be equal to V1 is equal to 8 volt. Now similarly for V2 we use Q is equal to C2 V2. Here V2 is equal to Q upon C2. 48 divided by 12. 12 fours are 48, then V2 is equal to 4 volt. Result of this question: in our first part, the equivalent capacitance 4 microfarad, and in B part, Q is equal to 48 microcoulomb, and in C part, V1 is equal to 8 watt and V2 is equal to 4 watt. Now we will move the last question, question number 10. Numerical problem, question number 10, given statement. Two capacitors of capacitance 6 microfarad and 12 microfarad are connected in parallel with the battery of 12 watt. Find the equivalent capacitor of capacitance of combination. Find the charge and potential difference of each capacitor. So write the given data according to statement. Capacitance C1 is equal to 6 microfarad. 1 micro is equal to 10 raised to power minus 6. So C1 is equal to 6 multiplied by 10 raised to power minus 6 farad. And capacitance of C2 is equal to 12 microfarad. Here same we write that not a 6, 12 multiplied by 10 raised to power minus 12 farad. So voltage V is equal to 12 volt. Now we can find the equivalent capacitance, and in B part we can calculate the charge on each capacitor Q1 and Q2. Also in a C part, potential difference V. Using the formulas for a first part, in a parallel combination C equivalent is equal to C1 plus C2, and in a B part Q is equal to CV, and in a same formula used for a potential difference Q is equal to CV but rearrange. Now let's move question number 10 solution for a first part. In first part, in a parallel combination C equivalent is equal to C1 plus C2, that is equal to 6 microfarad and plus 12 microfarad. 6 plus 12 is equal to 18 microfarad. Now for a B part, charge on each capacitor, so Q1 is equal to C1 V1. Then we calculate the values, putting the values. Q1 is equal to 6 multiplied by 12, that will be equal to 72 microcoulomb. And now for charge on the C2 will be Q2 is equal to 12 multiplied by 12, that is equal to 144 microcoulomb. Now for the voltage, the capacitors are connected in a parallel, so voltage will remain same on both capacitors. So V is equal to 12 volt. Now for the result of question number 10, in A part, C equivalent is equal to 18 microfarad and B Q1 is equal to 72 microcoulomb and Q2 is equal to 144 microcoulomb. And in C part, voltage will be same, V is equal to 12 volt. For more videos and more lessons, subscribe our channel. Best of luck. Allah Hafiz.